All right, welcome back to today's video. Today we are going to be looking at how to simplify cube roots with variables. In the previous video, we looked at how to simplify square roots with variables. Now, keeping in mind our rules that we learned from the last video, we were looking with variables that had exponents that were even or multiples of 2. This time, we're going to be looking at variables that have exponents inside the radical with exponents that are multiples of 3. Here's why. If I take a number, multiply it by itself 3 times, I have what we call a perfect cube. Now, if I find the cube root of that, I get 3. Cube root of 27 is 3 because 3 times 3 times 3, 3 times itself 3 times gives us 27. However, when it comes to variables, when I multiply it by itself 3 times, I'm not multiplying the variables. Remember, I'm adding their exponents. So 2 plus 2 plus 2, or 2 to the power, or 2 times 3, gives us x6. And if I find the cube root of that, what I'm really doing is asking myself, well, what variable times itself has, when I multiply it, is going to give me a 6. But what I'm really doing is asking what 6 divided by 3 is. So in the previous video, we were looking for an even numbers that we could divide it by 2, because there were going to be 2 variables with the same exponent. This time, we're looking for groups of 3, which means that exponent needs to be divisible by 3 to give me x squared. So, rule time. If I had the square root of x to the power of a, cube root, I should say, not square root, if the exponent is a multiple of 3, then we divide by 3. If it's not, then make it a multiple of 3. Subtract 1, subtract 2, subtract 3. Just like we manipulated the exponents in the previous video, we can manipulate the exponents in this one to get us a multiple of 3. Here's what I mean. If I had cube root of x to the power of 16, well, 16 is not a multiple of 3, but 15 is. So how do you get 15? Subtract 1. x15, keep forgetting that little 3. Cube root. X to the power of 1. 15 is divisible by 3. That gives us x to the power of 5 with just one x inside our cubed root. Let's try another one. Let's say I had cubed root of 64 m9. Now be careful with this one, because 64, right off the bat, you might think of square roots. But remember, we're looking for cubed. So what number times itself gives us 64? Should be 4. 4 times 4 times 4. So we know there's going to be a 4 on the outside. Unluckily for us, 9 is divisible by 3. M3. And that's it for this one. Let's try one more. Let's say we have a 3 on the outside, and I'm looking for the cube root of 128, a 9, b 21. pause this video and see if you can do this one on your own. When you're ready to check, let's get started. For finding the cubed root of 128, you could break this down, the 128, by prime factorization and then look for groups of 3, or you can list down your perfect cubes. I know our perfect cubes, we have 1, 2, 3, 4, let's do 5. 1 cubed is 1, 2 cubed is 8, 27, 64, 125. So let's check if any of these can go into 128. And in fact, 64 does, twice. So I can say 64 times 2, A9, B21. And again, we're doing our cubed root, the 3 is on the outside. 64 is a perfect cube, so I know that's going to give me a 4, because 4 times 4 times 4. A to the power of 9, 9 is divisible by 3. So I can say 9 divided by 3. That's going to give me a to the power of 3. 21 is also divisible by 3. That's going to give me B7. So all that's to say, I still have my original 3 on the outside. I'm pulling out a 4, pulling out an A cubed, pulling out a B7, and the only thing that's left inside is this 2. Clean up the outside. 12A cubed, B7 cubed 2. All right, that's it for today's video.